So in this topic, we're going to take a look at dividing polynomials, but we're going to do so using long division techniques. Now, obviously, long division with numerical values, right? That's a pretty easy process, and you've done that before. So what I think we'll do is it's easier to start with that as to make it known that it's analogous to that. All right. Quickly take a look and think about long division and remainders with long division. So give me a number that 42 is not divisible by. Not divisible by. What do you want to divide it by? 42 divided by what? 8? All right. So if I did that, I would write it like this, right? You learn long division, you know, when you're in like 5th, 6th grade or 4th grade, whatever it is. How many times does 8 go into 42? Thank you. Everybody can answer. I know these are obviously easy, but I want to get through the process to show you. Now, once I write down the 5 at the top, I write down that 5 because I know if I choose 6, what happens? Please answer these. I know it's simple, but it's going to help you in the next thing. If I choose 6, what happens? It goes over 42, right? That's why you don't choose 6. We're going to have to keep that in mind for the next example in a moment. Now, what do I do next? I multiply 5 times 8 and I bring down the 40. So this technique is going to be repeated. We're going to do this with variables in a moment, but you're going to do the same thing. And now, what do I do with that 40? Subtract it. The same technique is going to apply with variables in a moment. So you have to remember to subtract whatever you multiply by, or whatever you get as a product of your quotient, which is up here, and your divisor. This is called what? Anyone know the terminology? Quotient is the answer, obviously. We'll have a remainder. This is your divisor. What is this term? Dividend. Very good. You have your dividend, you have your quotient, and you have your divisor. So you multiply your quotient times your divisor, giving you a number here. Subtract that number from your dividend. This is your steps you would go through. You'd have a 2 here. Now you could obviously put a 0.0, bring down the 0, and get a decimal. But for now, I want you to make believe you can't. Like when you were younger, you learned about remainders. You would write remainder 2. Now, what does that mean about this answer as a mixed fraction? Or a mixed number, I guess. Not an improper fraction. Okay, what is, again, 42 over 8 as a mixed number? How could you represent 42 over 8 as a mixed number? Based on this answer, you can make that statement. What's 42 over 8 as a mixed number? 5 and? Not 1/8, be careful. 2/8, which is really 5 1/4. Well, where is she getting the 2/8 from? You can see it, obviously. The 2 comes from the, what is it? Remainder, always. And the 8 always comes from the divisor. So you see the technique, right? We're all clear with that? Now, you're going to take that idea and you're going to apply it to variable expressions instead of numerical expressions. So now we're going to look at polynomials with this exact same approach. So if you were writing notes down, here's what my notes would say. Under the 5, I might put the word quotient. Where the 2 is, I might put the word remainder. Where the 8 is, I'd probably put the word divisor. So I know I have a little bit of a template for this. Okay, and once you do it a few times, obviously, it'll become second nature and it'll become very easy. But again, we've got, and I'll point to them as I state them. This is your quotient, this is your remainder, and this is your divisor. It's going to follow that arrangement every time. Here we can simplify. With long division with polynomials, there's not much simplification that usually happens because they're variable expressions. Okay, quotient, remainder, divisor. All right, let's take a look at the first example. Divide x squared plus 2x plus 4 by x minus 3. So which is the divisor, which is the dividend? Which is which? Which is which?
Dividend is x squared plus 2x plus 4.
Agreed. And there's your dividend because you're dividing that by x minus 3. Now, this is where it gets a little bit, not tricky, but different than what you've done in the past. Ask yourself the following question. What can I multiply this expression by to get rid of the first term in my dividend? What can I multiply this whole expression by? I'd have to distribute it to both terms. But what can I multiply this by to get rid of this first term of the dividend? X. And let's go through this. Okay? So if I put an X up top right here, and now I multiply. Remember the rules. What were the rules? The rules we said was take the quotient up top, multiply it by the divisor out front, and put that value underneath your dividend. So take the X and multiply it by X minus 3. You get X squared minus 3X. Agreed? And now, what do we always do to that number? What do we do to that number? Earlier, it was 8 times 5 gave us 40. What did we do to the 40? We subtracted it from the 42. So what should you do here? Subtract it from the number above. So ready? Put the minus sign around the entire thing. I think Chandler was about to ask that question. It looked like his hand popped up. Did you raise your hand just now? Oh, I saw a hand. I thought your hand popped up. This, remember to put the negative sign there. Okay, please remember that it's outside the entire expression. When you subtract 40, you're really subtracting 4 times 10 and then 0 times 1. If you're subtracting 42, you'd be subtracting 40 and then 2, really. Both parts to the number you'd be subtracting, while both parts to the expression, the variable expression, you are subtracting. So you're going to have a double negative there, and that's okay. So when I subtract this, x squared minus x squared, what does it become? If it doesn't become 0, you did something wrong. Okay? It's always going to work out that way. You're always going to get a 0 in the first placeholder. That's the goal of this process, to subtract those first two terms and get them to cancel. And then you've got 2x minus negative 3x. Everybody? Or just Sarah, that works too. 5x. All right, this should be second nature unless some of you are already on the next example. And then bring down the 4, because it's going to be 4 minus 0. If it's not clear here, take a look. This is really a 0 at the end. Whenever there's nothing there, it's a plus 0 really, as a placeholder. So 4 minus 0 is going to give me 4. I could also just take the 4 and bring it down directly if that makes it a little easier for you. So now I've got this expression 5x plus 4. How can I get rid of the 5x now? My goal is to get rid of the 5x this time. Earlier, our goal was to get rid of this x squared because it was the leading term in the dividend. Well, now this is like your new dividend here. How do I get rid of a 5x? What should I multiply this whole expression by to get rid of a 5x? By 5. When you put a positive 5 there, we take that 5 and distribute that 5 to both terms in the divisor. 5x minus 15. And we subtract the whole thing. Again, take the 5 and distribute it to both terms in the divisor, making this 5x minus 15, dropping that here, and remembering to subtract this. The 5x's again cancel, making that a 0. 4 minus negative 15, 19. So, what can I do next? Can I pick another number or another thing to put at the top and then get it to multiply by x minus 3 to get rid of this? Is that going to be possible? If I multiply, let's say I put a plus 7 for some reason at the end, I'd get 7x minus 21. And the 7x would definitely not cancel with this. So at the point that your number down here, I don't know what to use as a term for this, at the point that your expression has a lower degree than your divisor, you stop. So if this were an x squared here, take a look up please. If your divisor were x squared, and at this point this was like 7x, you'd stop. Because 7x has an exponent of 1, right? 7x to the 1. Whereas x squared has an exponent of 2. So as soon as the degree of this is greater than the degree of this, you stop. And this becomes your what? Remainder. Okay? And then you simply write your answer as a mixed number like we did earlier. So earlier, we said the rule was this: quotient, remainder, divisor. Quotient, remainder, divisor. Quotient, remainder, divisor. So literally just fill those spots in. The quotient is what? What is the quotient in this case? Okay, and then we just simply fill in the remainder, which James just told us was 19. And what's the divisor again? What's the divisor here? Well, x minus 3. Okay? That's what our answer would be. And it's written as like a mixed number again. I know it looks weird, right? This looks kind of funky, but it is the expression you would get as an answer. X plus 5. Now, what goes here really with a mixed number? What's really in between it? 5 and 3/3. 5 and 3/4. I almost said 3/3. 5 and 3/4. What does that really mean? 5 plus 3/4, right? There's really a plus sign. We don't write it, obviously, with a mixed number. But here, I need to write that plus sign. Because these are variable expressions. I can't just separate them and assume that I know that that's there. So please put a plus sign right between them. Okay? Again, think back to what you would do if this were an example of something that were long division and not polynomial long division. All right? Hey, try the second one on your own, please. Own, please. Try to make some sort of conjecture when you're done with the problem, based on your result, please. Based on your answer, make a conjecture. Statement. That's what happens. What was your answer? I don't know what your answer was. What was your answer? Chandler, what do you got?
2x minus 3.
What was your remainder?
0.
Yeah, there was no remainder, right? Did a lot of you pick up on that? There was no remainder here? Yes, no? Yeah? Conjecture? What statement can you make now? There's no remainder. What statement can you make? Louder.
So it's
It's not a mixed number, good. Absolutely.
It's factorable.
Yes, that's it. Very good, Will. Great job. Will recognizes that really your answer is 2x minus 3. That comes out up here. I'll leave all the work down below to you. 2x minus 3 comes out to be evenly dividing into this expression, 2x squared minus x minus 3. So this is one of the factors. This is the other factor. Will, how did you recognize that? Did you just see it? Okay, if you're having trouble seeing it like you just saw it, here's what you do. Ready? Well, take a look at this. What's 42 divided by 7, everybody? 6, right? Well, what's the remainder? The remainder is 0. Because 42 factors into 7 times 6, doesn't it? Same thing. This expression here factors into this and this if the remainder is 0. It's a huge thing to recognize. We're going to talk about this for a while. In section 8.4 and section 8.5, it's going to come up again. We're going to talk about something called the remainder theorem. So it's really important that you see that when the remainder is 0, the expression that you started with, that you're dividing into, this dividend, can be factored. And one of those factors must be the divisor. The other factor, the quotient. Is that clear? Okay, the quotient and the divisor together make up the factors of the dividend when the remainder is 0. The quotient and the divisor make up the factors of the dividend when the remainder is 0. The last one is no more difficult than these two. It's just a little bit more extensive because you start with a cubic function and you're dividing by a quadratic. Okay, but you can definitely do this on your own still. Put the solution on the board. I'll go through all the steps, but I'll give you a minute at least to work on your own. Yeah, you've got a little bit of time still. Oh, man. So pause where you're at this point. Look up. Did anybody remember to leave that blank there? Anybody think about that for any reason? What's going on? Why did I leave a blank there? Can somebody fill in that? What should that blank be filled in with? Why did I leave a blank? Think about it. Come on. Will. Yeah, where's the x squared term? Later, when we multiply whatever you put up here times this, you're going to get an x squared term, aren't you? And that can only be subtracted from another x squared term. So I would put a 0x squared here as a placeholder. Okay, trust me on this one. Try it out. The 0x squared will help you to align all of your numbers. That concept of a 0 placeholder will come up again tomorrow. So when you, or Monday, when you hear it in the video, make sure to jot that down. That you're going to use 0 as a placeholder when you don't have a term in that polynomial. Playing sports? Basketball, soccer, and lacrosse. We don't have lacrosse, but we have basketball and soccer. We have a baseball team. That's like the guys' sports. And then girls have volleyball, football, soccer, softball. What position in soccer? Nice, defense. Good. How about basketball? So this one is just going to be a lengthy process. That's all it is, right? You've got to be meticulous with your work. A lot of room for error. Myself included. And just be careful with whatever you place there. Give me another second. What did you start with, James? What did you start with?
Multiplying by 3x.
Good. Okay. I would most definitely start with 3x. Because 3x times x squared gives me 3x cubed. Okay, so take that 3x, distribute it to every term in the divisor itself. Take the 3x, distribute it to all three of these, and write those three things there. And then I have to remember to do what every time? Whenever I do this process, I have to what? What am I doing? What operation? Subtraction. Okay, the whole thing. That's where the common error comes up. A lot of people don't subtract the entire thing. They subtract just that first term. So obviously this is going to be a 0 again. I don't need to put the 0 there. 3x cubed minus 3x cubed. I got a 0x squared minus 9x squared. And a 2x minus negative 15 is plus. And then I'll carry down the 4. Morgan, what did you put for the second part of this? 9? Good. Negative 9 times 3 is going to give me negative 27 for the x. Negative 9 times negative 5 is positive 45 here. I remember to subtract the whole thing. And again, negative 9x squared minus negative 9x squared is 0. 17x minus negative 24 is positive. So we're going to get, what, 44x? And then negative 4 minus 45 is going to be negative 49. So take a look at this point, folks. What is the degree of this expression right here? What is the degree of this expression right here at the bottom? What's the degree of this? What's the degree? Somebody besides Chandler. What's the actual degree of this bottom piece? Terminology we need to know. We need terminology. Chandler, what does degree mean again, Chandler?
Like the highest exponent.
The highest exponent. So the degree of this, Alex, what would the degree of this be if it's the highest exponent? What's the degree? 1. And what's the degree up here, obviously? So as soon as this degree is greater than this degree, you stop. So this means this is what? This expression, 44x minus 49, your remainder. So your answer at the bottom will be 3x minus 9 plus 44x minus 49 all over the divisor. X squared plus 3x minus 5. Okay, that's what your answer would end up becoming. So again, we always have whatever turned up on top of the division bar plus the remainder over the divisor. Okay, you have about a minute or two. Any questions on this? Any questions? Remember what I was saying? It's a process. What is the one way you can do better with things that are processes? Seriously, what's the way that you improve with processes? Yeah, practice. Okay, if you play sports, if you do anything with drama, anything like that. If it's a process that you have to memorize or something that's rote, which this is something that understanding is not very difficult because you already understand long division, but it's the process itself that you have to practice. Okay, make sure to do your homework.